soar, use your own AI, we'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, welcome back to the AI office hours, and Alex and I here in person at another NEAR.AI offsite. We've been cooking some really cool stuff. We're gonna give you some alpha now, and then you obviously learn more at Redacted in a week. So Alex, let's dive in.
Let's do it. Okay, problem. There is a problem. AI is taking over the world. Everything AI happens inside of large profit-seeking corporations. All our data goes into their databases and data sets. We're repeating the same mistake we've done with social networks, the same mistake that we've done with the search engines. We need to stop it now. For that, we need a plan, and we will lay out the plan right now. Shall we?
Well, maybe the other part is we, kind of as a space, we believe in open source, but the challenge has been that open source doesn't have inherent monetization approach, right? And even more, there is actually a fact that if you build something in open source, any of these labs can take it and use it, and it doesn't work the other way, right? Yes. You have this asymmetry that is clearly benefiting any closed lab and undermining open source research.
Like case in point, Elasticsearch, and like dozens of others.
Yeah.
Okay. So let's say that GPT-5 is happening any moment now, right? So GPT-4 is no longer the battleground, even though nothing really caught up with GPT-4 in open source. But GPT-5 will appear any moment now, and then Claude 4 or whatever version they will choose, 4.5 probably. So let's say that we believe that to compete with that, we need to train a 1.4 trillion parameter model. 1.4 trillion parameter model. That is, we did some numbers with Illia today, and we concluded that training 1.4 trillion parameter model will cost approximately $150 million. Right, it's a massive amount of money, and there is a chance that we can do it, that once we can pull enough resources to train a model of that size for the benefit of humanity, right? But the race doesn't stop there. So a year from then, or 2 years from then, OpenAI and Anthropic have new models, open source does not, right? We stop forever at 1.4T. The next model costs $300 million to train, the next one is 1 billion. We have no chance to catch up. So the first problem we need to solve is how do we train a model in such a way that it's economically viable, right? So people do not just, donate money to train it, people actually invest money into training it, and then, in some way or another,
it returns on this investment in such a way that it can reinvest to the bigger model.
Into the bigger models. At the same time, obviously, we do want the properties that you can use the model without your data leaving, without it going anywhere, provably, right? Not just like, someone said, hey, I'm a corgi, trust me, I'm not going to use your data, right? And we want to make sure that, if I want to have the model locally, I need to be able to get it locally. That's problem number one, right? Problem number one, economically viable. Problem number two is eco. Eco would be ecology. Problem number two is consider Llama 405B. Llama 405B presumably is almost the same size as the best models today from proprietary providers, but it's not as good. Right? I don't think anyone would say that Llama 405B is as good as GPT-4. So what we learned from that? We learned that it's not that easy. It's not just the parameters, right? There's something else, right? And in order, if we get the money and we train the model and we can monetize it, it's still probably not going to be competitive, right? So we need a way to create a competitive model, competitive. And OpenAI has, the best researchers, they go to OpenAI, and they have in a single place, they have all the data, all the models, all the resources, all the experiment results from the past, all the expertise in a single place, right? In the open, first of all, it's much harder to get the same number of the same quality of people concentrated in one place. But second of all, even if we bring them, they don't have access to that. So yeah, let's talk about solutions. Let's talk about solutions and let's begin with an interesting one. How do we train a model in such a way that everybody doesn't just use it for free, right? But it is privacy preserving and available to everyone. This is where we use the magic of a technology called trusted execution environments. So on modern processors, like Generation 5 Intel Xeon, there's a technology called TDX that effectively allows you to do something that sounds like magic. It allows me to run code on Illia's machine, even if I don't trust Illia at all whatsoever, in a way that I know, first of all, the code that is running is in fact code that I think is running, and two, Illia cannot see anything. All he knows is that something is running, but he cannot see the code, he cannot see the data, he cannot see anything. So the way it works is like in the processor itself, there is a vault, and which allows you to which runs like there's a barrier between that vault and the external processor, and so it doesn't see anything that happens inside. And then within that, there's a key that Intel knows, right? And so it can sign and attest to a lot of things, and then Intel will tell you that the attestation is correct. So it's not quite as magical as it is because we have to trust Intel, but this is way better than trusting random people running servers on the internet, right? So TDX.
Well, and you're trusting Intel to effectively print chips.
Yes.
And
yeah,
you're not trusting them to run
Intel already. Yes.
Yeah, you're not trusting them with like running, passing data, etc. And we're really trusting them indeed that they're going to make chips that are following specification, actually doing the computation we need.
Right, and so TDX is for processors, and starting with H100s, the latest, not latest anymore, right? One of the latest GPUs from NVIDIA, they have the same thing, right? Meaning that if your processor is TDX enabled and your GPU is at least H100, your GPU computation can have the same properties, right? So you can do that. Immediately allows you to do private inference, right? So like Illia can spin up a private inference server, and I will send, a request, and I will be able to know before I send the request, I would be able to verify that Illia will not be able to spy on it. And after I send it, I get the response throughout. I know that as long as NVIDIA and Intel do not conspire with Illia, Illia has never seen my data, which is great, right? This is something that on itself is already value, even before we go.
Yeah, so effectively you can verify that Bob runs a TDX-enabled image that is exactly to specification that you require. And for example, the specification is a AI inference model, and you can actually get a key with which you can encrypt the data that only TDX can decrypt, run inference, and respond to you back with encrypted with your key. Meaning Bob only sees request response with effectively attestations and encrypted data going in and out.
Right. So how do we use this technology to train our 1.4 trillion parameter model in the way that it is economically viable? What we can do is we can train the model fully in TEs. TE stands for Trusted Execution Environment. So those vaults are they call TEs. So you can train the model entirely in TEs. So at every step, every parameter update, every forward, backward pass, everything happens inside the TE. So at no point any of the participants of the training see the actual weights. All right, so at the end of the training, what you get is quite interesting. You get a model for which the code that was used to train it, and the data, all the data preparation pipelines could all be open source, and moreover, you can prove, again, as long as you trust Intel, that the model you have is in fact produced by that code using that data. Something you cannot do about, with none of the models today have that property. And then that model, it is encrypted. Nobody has ever seen the weights. The only way to get the weights is to use a specially crafted virtual machine that is running inside of a TEE, and that specially crafted virtual machine is guaranteed to give you the response to your prompt for as long as you establish a payment channel on NEAR with it and pay a little bit of, like a tiny amount of money, right? But tiny amount of money accumulates very fast if a very large number of people uses the model. So as long as it is actually a very good 1.4T, that's a very viable approach, right? So it's a model that has the properties that you know how it was trained, you know exactly the code. If there's any bias, you can verify, you can track it down. You can have it locally. You can spin up your own machine with the last generation processor and the H100s, and you can pull it. Like, the VMs just have a protocol where one TEE will pass it to another. All right, so as long as you know anyone who has it, you can get it to yourself.
Or, I mean, it can be encrypted in decentralized storage, and
Yeah.
you can pull it from there, and only your TEE can decrypt it.
Well, TEE needs to talk to another TEE to get the key. Yeah. But yeah, the encrypted model is somewhere. The key is only need to communicate to pass the master key. Yeah, but at the same time, there is no way to use that model without actually paying for the usage. So that is it effectively solves all the problems, right? It creates a way, an economically viable way for the community to build frontier AI models, to fund them, to build them, to monetize them. And by default, fascinatingly, by default, it has private inference, and moreover, you can build it in such a way that there's no way to use it without private inference. So it's so like there is no way, if it's built properly, there is no way for someone to shoot themselves in the foot, right? Whenever they use that model, the inference is always by design private.
You can also obviously fine-tune it privately. You can fine-tune it on private data. And so new kind of derived versions can be private. You can also guard, let's say you fine-tune it on your data. You can say that only you effectively can use it, or you can share it and monetize on top effectively. When that model is charged, there is like, set of kind of distributions that happen, part to the hardware provider, part to the people who build the original base model, and then part to whoever fine-tuned it. And you can keep stacking it, right? And so it's effectively like you program kind of for every inference, you can program how much of different parties will receive payouts.
Okay, cool. So that being said, if we don't have the same researchers, OpenAI and Anthropic, the model is still not going to be great. We will spend 100 million to train a model. It will have all the properties I just described, but it's not going to be good. So how do we make it good? Effectively, the idea would be to build. First of all, we want to build a central but decentralized place where all of that is pulled together, right? Like one place where you have access to compute, to code, to data, to agents, like effectively a large hub which stores, like you go there, you publish. It's like decentralized Hugging Face, right? It's a single hub where you can publish resources, you can find resources, you can, with the help of TEs, you can also monetize resources, but let's not get there just yet. Right, and then we would bring, for every model, we would iteratively go from small models to the large models, and at every stage we would say, we would have a competition, right? We will bring a lot of people, we will have resources allocated for it, and the researchers show up and they compete. Their goal is to create, there's a benchmark that is used to measure their progress, right? And and you begin with a smaller model. Like, let's say we begin right now in our little calculations, we use the size of 0.5 billion parameters. I'm pretty sure you cannot see there. 0.5 billion parameters, right? So it's a very small model, which has a property that you can train it
on one machine.
On one machine in one day to an amount of data which is very reasonable for a 0.5 billion parameter model, right? And so with such a size, we can have a, like with a reasonably sized cluster, we can have a competition with a very large number of participants to whom we can provide compute, right? So so that's a first step. And then at every consecutive step, the model gets bigger and bigger, right? And right now we're considering 6-7 steps to get to 1.4T. But at every point, only the top K participants advance to the next round. So the number of participants is smaller. The number of compute that we have is bigger and bigger, right? We're going to be accumulating more and more compute as the model gets bigger. So it's, at every step, it's viable for that set of participants to come up with a great model. And when we say great model, what we mean is data preparation, primarily data preparation. I think the biggest differentiator between the model quality, model's qualities is how well, the data is deduplicated, how well, low quality data is removed, how well, what sort of data you augment your, internet dump and GitHub dump with, etc. But then also, yeah, hyperparameter tuning. So like, learning rates affects it quite a lot, and other things, optimizer tuning, in parameter initialization. So there's plenty of things you can do that will affect like gradient clipping and whatnot. Yeah. And starting, go ahead.
Yeah, I mean, I think the interesting part here, as a researcher who participates in this competition, you have a fixed budget of compute. And so now if you can write a more optimized code, you now have a leg up because you can actually process more benchmarks. So this naturally also invites people to optimize and kind of contribute to have a more performant code, as well as models get bigger, you will have access to more machines, and including in a kind of distributed cluster where they're not interconnected with kind of hyperconnectivity. And so you can also, like, competition naturally starts to also incentivize figuring out how to do distributed training, decentralized training.
Right. Yeah, up to certain size of the model, up to anything that is trainable on 4,000 GPUs, let's say, give or take, it is still relatively easy to get a cluster of that size. All right, but for a 1.4 trillion parameter model, the cluster size is getting, to like, high tens, low hundreds of thousands of GPUs, meaning that, like Elon and a couple others have this cluster, but for us it would be relatively challenging, right? So our options is either to, well, go to Elon, or
pull together multiple
clusters, right, and find a way to train across clusters. And that is, I think, like, the research is happening. There are multiple companies in the ecosystem that work towards that, and either they will figure it out and we will just work with them, or we will also start, in the same format. Like this competition format lends very well to figuring it out, right? And then at some point, I guess we mentioned it multiple times already, but we have a active project on NEAR that, where we explore data annotation. All right, so once we move to fine tuning, today, it's not very well known how on which data sets those big models are fine-tuned. All right, so like GPT-4, Claude, Llama, we know they are fine-tuned on something. We don't know on what, but in a decentralized manner, there's a very good chance that we can create very good data sets for fine-tuning very quickly. Right, so similarly to how in the pre-training step, researchers will have access to compute resources. In the fine-tuning step, they will just have credits to launch arbitrary data annotation tasks, and there will be a pool of people ready to pick them up, right? And so, like at the fine-tuning step, now you can, compute-wise, it's a very cheap job. Like fine-tuning a model, you fine-tune on a fraction of the data, but that data now needs to be extremely high quality. This is where data annotation potentially is, or like synthetic data, is potentially way more important than filtering down massive data sets, right? So it's
or you can have this directly in with your model for RLHF, where you have humans feedback directly into the model. And so so the process is effectively there's competition going. The 0.5B is ongoing competition. There's finalists decided. Based on the kind of finalist submissions, the production run is started for that size of the model, because you want to train for longer for kind of prod use, and then fine-tuning starts from that as well.
Yep. And then somewhere along the way, we figure out similarly, we can, like in this competition format, we can effectively, I'm being ambushed here. Okay. Okay, that we will need to cut out from the final version. In the same competition format, we can figure out a lot of other things such as multimodal, voice. I guess voice is multimodal. As we mentioned, training over slow networks, potentially and oh yeah, like chain of thought, things like like OpenAI Strawberry. Again, that would be an interesting competition, and that's actually something we're working on right now, where we will be launching relatively soon one of the competitions where the goal is to solve interesting math problems using chain of thought or some sort of reinforcement learning. So it's
yeah, there's other types of competitions kind of on the side that can augment the main push for the frontier model.
Yep. So that's the plan. That's the plan, and we started executing on it relatively recently, but full speed. There's going to be more alpha at redacted, which happens in 4 days.
6 days.
In
November
6 days.
10th.
Yeah, November 10th. Cool. What else do we want to cover here?
Well, I think the maybe interesting questions. I think this part. I mean, we talked about like data prep, curriculum learning back at the first whiteboard. I think the interesting question to kind of highlight a little bit of the existing work on decentralized training, and yeah.
Yeah. Okay. So decentralized training. First of all, there are existing efforts, right? On top of my head, I know of NEAR.
Yeah.
Yeah, NEAR and Prime Intellect. The former, I don't think their approach is known. There is only a technical report, but the latter is building on top of a technology called DeLoco, which is a DeepMind paper. So I guess interestingly, Google for some reason is interested in training over slow network. I guess their clusters, are there clusters all over the place?
I mean, they have
potentially
hundreds of data centers.
Yeah. And we had a reading group with DeLoco. We have a video. We will publish it soon. So we will have, it's like a 1-hour discussion, diving pretty deep. The paper itself is relatively short, but there's a lot of experiments, and those experiments have caveats. So that's an interesting video. Stay tuned. And then on top, so DeLoco is very straightforward. They effectively just change the optimization process ever so slightly so that you train the model across many different clusters, but it still has a requirement that every cluster can fit the model, right? So effectively, you cannot have, if your model doesn't fit on a single box, it means you cannot just have a network of disjoint machines. Still, every node in the network would have to be a small cluster with InfiniBand. But the follow-up paper from DeepMind called DePaco.
Yeah, so maybe just effectively have replicas of the model that are updating on different parts of the data set, and then there's a process that sends their accumulated updates to a parameter server, which runs a little bit different optimization process to update parameters, and then now kind of new parameters are being sent back.
Yep. So an interesting thing in DeLoco is that they show that if you only keep one replica, but still use DeLoco instead of just training using Adam, they see better results than just training using Adam, which is slightly suspicious, but it's an interesting, one of the interesting things in the experiment section in the paper.
So this is example, by the way, of right now, the way research is done, when you're observing outside, you get effectively a paper, which is a snapshot of work. You get some benchmarking that happened on their experiments, and you kind of need to decode what were the parameters and what are the different trade-offs that they made. The idea was kind of open competitions, especially on this effectively infrastructure that allows to validate that exactly this code and exactly on this data was run, you can, try to reproduce these experiments. You can actually show what are the differences, and people can go and actually look at it and fork and modify and build on top. And so that's really right now, the lack of this infrastructure is hindering open source development, as well as reading papers. Like, you cannot reproduce these experiments effectively, even if you had compute. And if you don't have compute, it's even a higher problem for anyone who's trying to do research in this area.
And I guess there are papers with open source, with open source code, but it's not as simple. Like, the beauty of this hub that was on the previous page is that the way a person submits their job is like, they say NEAR.AI submit, right? And it goes to the worker, and the worker, has a very specific way of pulling resources, meaning that for someone to reproduce it, all they have to do is to say NEAR.AI submit, right? And they know that, it will go to the worker, be able to train. So yeah, like, iterating on experiments is very simple, right? Because once you fork an experiment, you know that in its current state it works, right? So like, if you, if it's an open source repo, you need to reproduce exactly the setup in which they were running it. You need to pull the data in exactly the way they expecting it to be pulled, etc. Figure out the dependencies, libraries, right? Cool. Yeah, and so there's a follow-up paper from DeepMind called DeepACO, which tries to solve the problem with models not fitting on a single machine. And that one is way more involved. It's not just, a small change in the optimization step. And the experiment section is, if you try to extract apples to apples comparisons, you will notice that DeepACO is not doing as great, which is probably sort of something you would expect when you, because it's only using a subset of parameters on every pass. So, but it is a great first step, right? And so from here, again, in a form of a competition, we can push it forward and hopefully figure out a way to train a massive model in a decentralized manner. Though I guess it wouldn't be as important for us that it fits on a single machine. I guess if people are spinning up machines with H100s and Gen 5 CPUs, they probably can have small clusters. That's not an unreasonable assumption, right? If you go to GPU list AI, there's plenty of those small clusters. It's just that having 100,000 of them in one place is a challenge, right? But yeah, I guess like having like tens of them in one place is quite reasonable.
Yeah, and for 1.4T, you effectively need something like 15 machines with 8 GPUs each to fit. So yeah, you the minimum size of a cluster is that.
Yeah. So DeepACO might not be necessary, right? Like we can, it can be just, like the idea would be, the participants of the training have 16 node clusters, of which there's plenty right now. Like Lambda, exhibits, a lot of them will give you clusters of that size. Cool. What else is interesting? Well, let's talk a little more about the hub. So, let's talk about this interesting idea. So I kind of discarded this idea of the, not discarded, but brushed off the idea of the monetization, right? But a lot of data is, people have proprietary data that they would like to monetize, quite a lot of it. And it's a very hard thing to do, because once someone else has your data, they can, they have it, right? Yeah. They can replicate it, they can use it for free. Like, it's fully, right now it's fully reliant on licenses and people, honoring licenses. But TEs change it quite drastically, right? So you can have, if you already have a place where all the data, all the code lives, right? You might as well, and that place happens to be on a blockchain where money is a native primitive, yeah, you might as well go and introduce monetization, where you say, hey, this is my data set, and you can use it to train your models, but you can only do it in the TDX. Data set is encrypted, and only inside the TEs, right? And every time you do that, you have to pay me, right? And if you use a subset of it, you pay me, like the same thing with the payment channel, right? So suddenly you can monetize your data and be quite certain that your data is not going anywhere. Same thing applies to potentially smaller models, right? So it's one thing where we train like the model on the path to 1.4T. People might have some other ideas specific to particular use cases where they train a model based on their proprietary data, maybe proprietary ideas. They can publish it and say, hey, guys, you can use my model in a very same way. Establish a payment channel with a T. I get paid every time you use it, but you can even have it on your machine. As long as I get paid every time someone uses it, it's great. All right, so that effectively allows you to have a marketplace around all the data, models, agents.
Yeah, so the benefit this TDX allows to run potentially arbitrary code. So your agent usually is some program that has some AI element, LLM element, and has potentially state machine and lots of kind of execution. So this itself can also run inside. So you have private execution over potentially private code of the agent, although there's like set of assumptions that you need to apply or limit it to accessing internet for that. And this allows, for example, to have marketplace where you say, hey, I want somebody to do my taxes. There's multiple agents that are bidding on this. You select one, you upload all your tax documents, which you would never give to any particular party. And now they're able to run, interpret, generate tax return, and kind of return it to you. And neither people who wrote the code for this agent, people who trained this LLM, or where it executed were actually able to access the data that was in flight.
Yep. And because compute is part of the center, how do we call it? A hub, right?
Yeah. Part
of this hub. You don't need to have any infrastructure locally to do any of that, right? You just show up there and say, hey, I want to use the data potentially to fine-tune a model or like use a fine-tune model. All of that happens in a click of a mouse button. No need to have infrastructure locally. Or if you have infrastructure locally, you don't have to trust even with like in some cases you literally want your machine to be offline, separated from the internet. Even that use case works. Despite the fact that it's a payment channel, you can structure it in a way that the payment channel is pre-created with slightly different parameterization, and then you just put it on like a a flash drive
or a QR code.
Go to your vault, yeah, or like on a QR code, yeah. Go to your vault, enable it, and for as long as the payment channel is not depleted, you can use it completely offline. So that's
yeah, so I mean that's a really cool feature because like the payment channel that you establish here, you effectively prove that you deposited some money on the blockchain, and so now TDX can verify that, and this can be verified offline. But importantly, to close a payment channel, you need to request a kind of closing message from TDX, and that allows to as well TDX kind of to prevent double spends in this payment channel.
So generally with the payment channel, that's actually an interesting technical thing, not particularly rocket science, but it is interesting, right? Because usually if you and your counterparty want to have a payment channel, you don't trust your counterparty, right? So you need a protocol where you can, like generally the way payment channel ends is that we both send to each other a message saying we're ready to close the payment channel, and then any of us can close it by providing this transaction. But because we don't trust our counterparty, we cannot expect them to send us that message. So there's always a protocol for payment channels where I go on the blockchain and say, I want to close it now. My counterparty, is not cooperating. And if I do that, I might be the malicious actor. I might be trying to close the payment channel in a state that is stale, right? Where there's a more recent state where I paid more money, right? And so in this case, my counterparty must be able to go on chain and say, like there should be a grace period where the counterparty have to be able to challenge. So, that naturally doesn't work if the TDX is offline, right? If it's offline and I started a payment channel, I paid it for a lot of inference, and then I go back to the blockchain and say, hey, the payment channel is actually closed at the very beginning. I never paid anything, right? And TDX, living in isolation, cannot do anything about it, right? But the thing is that we absolutely do trust the TDX, right? So as long as it doesn't crash, as long as it is online, we know it will send the message if we ask it to do so, right? So we can change the parameters of the payment channel to say that we cannot close it using, a message which is not authorized by the counterparty, right? And so this way, like effectively, the thing inside the TDX will say, I either need to be online when we're doing inference, right? I need to be able to check that, like at least as of right now, you haven't tried to close the payment channel. In this case, you can open it with an ability to close without a closing message, like a standard payment channel. And you would be able to, even if the TDX crashes, you still can close the channel. It will not be able to challenge you. Or you can go to the one that is offline. It's like I'm offline, but the payment channel you're trying to use does not allow you to close it without me authorizing it. So I will gladly use the payment channel, right? And so that the TE will close the payment channel for you if you ask it to do that. And the TE knows that you will not be able to close it without its authorization, right? So then it can be completely offline. And your only risk is, if it crashes, if it gets wiped out. But then, so that's a trade-off, right? You choose how much you want to put in the payment channel, understanding the risks. But it's a viable solution.
And for those who are coming from AI side, the payment channel here is effectively paying for credits for using the inference. And so it just, in this case, like you can, like if you have your own GPUs, right? You don't need to pay the cost of GPUs. You just pay whatever the cost of the model you run. And if you are running on the kind of shared cloud, then you're paying for the cost, and that presumably will be still dominating the price most of the time. It also, this system also kind of motivates people to optimize inference code as well, because now you have kind of unified infrastructure that everybody can push and benefit from.
Yeah, and there's a marketplace. If your machine is if your inference is cheaper, you can have a lower price.
Yeah,
naturally.
And so so then you're able to effectively just buy some credits for any machine and use them, and it just kind of routes you per request or per batch of requests to machine or mini cluster that actually can does inference on them.
Yep. Yeah, and the payment channels also, a great thing to have for agents to pay each other. That's also a primitive that will be available to people. Yeah. And I think one important thing to mention here is that it's not necessarily our goal to go and build all of those components. That's a lot of work, right? But there are for each of them, there are already people building them within the ecosystem, right? So like, Exhibits is building compute, and there is no reason not just to have, like that is just Exhibits, right? And so for every, like thanks to the blooming ecosystem on the intersection of artificial intelligence and NEAR, most of those things are already happening, right? And so, the hub will be just a place where they all
come together. And effectively creating this evolutionary pressure to keep improving.
Keep improving
in a coordinated way. Yeah, I think one of the interesting meta points is that there's a lot of excitement and a lot of people doing different parts of the work, but indeed it's like right now everybody needs to collaborate peer-to-peer, right? Like I'm working on agents, I need some compute, so I go to Exhibits. I need some new model, or I want to run some experiments to fine-tune. I need to find somebody who can do that. And so you have kind of lots of overhead just like coordinating this effort. And again, this is how centralized companies are effectively able to move fast, is because like this is all in one repo, all compute is in one cloud that they use, and everybody's in the same Slack. And so you're able to, move way faster with this. So we're trying to really bring a lot of the same kind of principles, but allow to combine all of the resources of existing companies as well as existing talent in the open source ecosystem by matching them with the resources.
Yeah, like a good example is so one part of that works already very well is the inference, right? So we have an inference router where if I want, I need a completion from Llama 405B, it's not as important for me who is doing the completion as long as it's the right model, right? So we have a router, right? And it can go to Fireworks, which is Web 2. That's how we call the things. Web 2 inference provider. We have Hyperbolic, which is Web 3, right? And for me, what matters is that it's cheap and it's correct, right? So inference router will pick the best route for me, and inference is it's very hard to fully win the market for inference, right? Like I'm pretty sure hypothetical hyperbolic would prefer that everybody just goes to them and there is no router, right? But because inference is a competitive market, it's great now, right? That developers don't need to integrate with 100 places, right? But also hypothetical hyperbolic, as long as they provide the best quality for the best price, they will be naturally picked, by the router or by people in the config, and so it's a it's a win-win for everybody. Easier for developers, companies capture bigger share of people as long as they're good, etc. Right? So like inference, I guess inference is here as well. Like inference is one part that of the hub that at this point works very well and is integrated with the downstream providers.
All right. Well, I mean, this is a lot already.
Yeah. Yeah, I think that was a good chunk of information.
So yeah, I mean, there's obviously a lot more going to be coming out as we develop this, and as well as a lot of projects in the ecosystem developing things. Some other interesting things obviously is that agents themselves are kind of through this model can have set of effectively secrets, right? This can be private key, this can be API keys where they can act on either their own behalf or on behalf of the users. So you can either delegate them some permissions, or you can have a fully autonomous agents, right? Which actually are not indeed like behaving on behalf of any user, right? This is effectively a smart contract like agent that can act on its own behalf and now transact. It even can raise its own money and pay for its own inference in the future.
Yeah, not only by providing my secret, not only I know that the owner of the machine will not see it, I also know that the agent that is using it is actually the agent I need it to be, right? So that's an interesting property that, or like if I'm relying on a particular response, I know that it was an agent that I thought it was supposed to be, right? So TE is also enabling quite a few use cases around agents. So it's all in all, TE is a magic.
Yeah, I mean, important, like this TD, like the previous generation of Intel TEs were very limiting and kind of had a very limited use case. And
had issues.
And had a lot of issues. This is a new generation that has...
it's much better.
Yeah, a way more kind of generic framework which allows even to run the full operating system inside it.
Not even, but it's like the way you're supposed to use it.
Yeah. And same for H100, effectively is the first GPU that supports working directly with TDX.
Yeah.
I think the other maybe returning back to the economic viability, right?
Viability.
Viability. The interesting thing here is effectively you can imagine a few different models of pooling compute resources for this. And you can have effectively per model token where you're raising funds as well. And through that, then obviously it's a token, so you can actually resell it before it starts operating and making revenue. But then this revenue is distributed to the token holders, and so that is all kind of being done through payment channels, repaying back to the token holders. So effectively creates kind of an autonomous way of pooling resources, starting a training run, and then with that encrypted parameters, then repaying back as they used for each million token, effectively the cost that was set by the DAO. And the cost can actually go down, right, over time as this model maybe become less viable, and then over time it can be open sourced. Yeah. Open
it's
parameters.
It's less viable, it's just there's a better model now.
Yeah, better model, so it makes sense to kind of discount the price. Yeah. And then also like over time potentially can open up parameters as well if that's like token holders which would require effectively re-encrypting data or decrypting data through the TDX.
Yeah, I think that's
a lot of alpha already.
That's a lot of alpha. Yeah, I think that's so that's yeah. It's hard to put in words how excited we are about this direction. So yeah, the future is pretty bright.
It's near.
And it's and it's definitely near.
Yeah, I think the kind of the thought we've been trying to figure out is, like, given the user ownership, right? Given how do we have these guarantees that we want and privacy we want, you need some machinery to ensure that, and you need a way to pool kind of talent and resources. And this is actually all of the pieces coming together, kind of enabling this and really moving us forward. So yeah, really excited, and more to come at Redacted.
Yeah.